In programming, your code needs to be flexible and handle multiple different scenarios. Flow control allows us to define different paths for our code to take while running. The first way we can create different paths is by using an if statement. Think about all the apps you interact with. If you have unread messages, you might see some icon that's not there when they're read. If you like a video, it might change the color of the like symbol to show that you liked it. If you're trying to change your password, you might have some error message that doesn't disappear until you've satisfied the constraints. With an if statement, you can choose what to do based on some condition. Consider code which has temperature stored in a variable. You might want to do different things based on what that temperature is. To demonstrate this, we'll create a variable, const temperature, and we'll assign it a starting value. From here, we can create our condition. We'll say if temperature is less than 60, and in this case, we'll console.log, it is cold outside. And if we change our temperature to something like 70, and run this again, we shouldn't get anything logged, as temperature is now greater than 70, which doesn't satisfy this condition. Therefore, this code block will no longer run. With if statements, we can optionally create additional clauses by using if-else. So let's create a few additional clauses. First, we'll say else if temperature is strictly equal to 70, we'll console log it is perfect outside. We'll add another else if temperature is less than 80, we'll console.log it is nice outside. And then lastly, we'll add an else statement, which will be hit if none of the other conditions are met, and we'll say else console.log it is hot outside. Now this time when we run our code, since temperature is currently set to 70, it should not fulfill the first condition. Therefore, it will check the second condition, which will be satisfied, temperature is 70, and it should log it is perfect outside. Because this condition is met, it will end the statement here and no longer check the other conditions. And when we run it, we see that it does print, it is perfect outside. Now let's try changing it to 90 degrees. When we do this, the first thing we notice is TypeScript's not very happy, and it says temperature is never going to be equal to 70. That's because we hard-coded temperature to be the value 90. So we should probably declare a type for temperature to be number in this case, since temperature could be any number. And when we run it this time, we should get printed, it is hot outside. So to recap the if statement, first we use the if keyword, and then we provide it a condition, and a code block to run if that condition is met. And then optionally, we can create as many additional conditions we want using else if. And finally, if we want, we can add an else clause to catch all in the case that none of the other conditions are met. The next way we can control flow is with a switch statement. Switch statements are a lot like if-else statements. However, in the switch, you can only compare against exact values. So it'd be similar to temperature is exactly equivalent to 70, and you can't do other conditions such as temperature is less than 60 when using a switch. Switch statements are great in cases where you have a fixed set of possible values that you want to compare against and run different things based on those values. For switch statements, let's assume we have a variable which tracks the current day of the week. We'll say const today, and the current day for me is Thursday. Now to create our switch statement, I'm going to type the word switch, and you'll notice that VS Code gives you some IntelliSense suggestions. I'll select switch and it'll autofill the boilerplate code for me. So in here, what we're trying to run our switch on is today, and we'll create our first case for today, which is Thursday. And for Thursday, we'll console.log midweek. And when we run this, it should console log midweek as today is Thursday. We have a fixed set of days of the week, so let's create cases for the rest of the days. We'll start with case Monday. And for Monday, we'll log ugh, it's Monday. And to end a case statement, we need to use the word break. If we don't include a break statement, the cases will continue to fall through and execute further cases. This isn't really good practice, and you should always use a break statement for each case. For the sake of this example, let's go ahead and see what it looks like if we allow for fall through. So we'll say case Tuesday will fall through to the same case as Thursday. And we'll also say case Wednesday will fall through to the same case as Thursday as well. Next, we'll create our case Friday. And for Friday, we'll console.log. Yay, it is Friday. And for Saturday and Sunday, we'll allow for fall through as well here. Case Saturday and case Sunday. We'll both say console.log. It's the weekend. Now you notice my VS Code is not happy with me again. It's giving me these red squiggles saying type Tuesday is not comparable to type Thursday. And that's because once again, we didn't specify the type for our variable. So we should go ahead and specify the type to be of type string, as this could be any string. Really, it would be better if it was an enum, but we'll cover enums in a different section. We can change our day to be Saturday. And when we run it, this time it should print it's the weekend. So for the default case, we'll say console.log. Are you sure you spelled the day correctly? And let's go ahead and run it again. When we run it again, we see two things printed actually. It's the weekend and are you sure you spelled the day correctly? See if you can spot the mistake. The mistake is that we didn't put a break statement here, and we also didn't put a break statement here. Without the break statements, when a case gets triggered, it will continue to fall through and run the rest of the cases below it until a break statement is hit. This is why you should always have a break statement at the end of your case, and fall through can cause abnormal behavior. So this time we'll spell our day incorrectly, and when we spell our day incorrectly, it should only hit the default case. To recap the switch statement, we first start with the switch keyword. Then we give it the parameter that we want to use as our condition. Afterwards, we create cases to compare that parameter to distinct values. So in this case, we'll say, if today is Monday, console log it's Monday. We can continue to create as many cases as we want. And if we don't use a break statement, when a case is ran, it will continue to fall through and run code in subsequent cases until a break line is hit. Now, lastly, we can create a default case for the scenario which none of our other cases are met. Both if and switch statements allow us to create different paths in our code to run based on certain conditions. But what if we just want to run the same code multiple times? For this scenario, we could use a loop. The first loop we'll look at is a for loop. Think about the scenario where you have an array of employees and you want to find their average age. For this, we'll create a list of employees. In my employee list, I have 4 employees with ages 30, 52, 41, and 25. We want to find the average age of our employees, but we also want to do it in a way where if we have more or less employees, the code will still function. The first thing we need to do is we need to add all of their ages together. To do this, we'll create a variable, let age sum equal 0, and we want to iterate through this array and add all of the ages into this one variable. For this, we'll use a for loop, and once again, we can type the word for, and VS Code should give you a suggestion to fill out the boilerplate code. In the for loop, we'll say let index equal 0. This is going to create a variable named index starting at the value 0, since our array is indexed from the value 0. The next part, where it says index is less than array.length, is saying continue to do this loop until this condition is met. For us, the array is not named array, but is named employees. And then the last argument is index++, which says increment the index after each iteration. So what this code block will do is it will effectively run for each element within this array. So in the array, what we want to do is we want to say age sum plus equals employees bracket index dot age. To try this out, we can console.log age sum, and when we run it, we should get the number 148, which would be the sum of all of their ages. To do what we're trying to do, which is find the average age of all of our employees, we'll say const average age is going to be the age sum divided by the number of employees. And then we'll console.log average age equals average age. When we run this, the total age is 148, and then the average age is 37. In this example, our index didn't really matter. The only thing we were using the index for is to get the employee associated with that index. For this, we could actually use a for of loop to make the code slightly cleaner. We'll delete our for loop, we'll type for again, and we can see a suggestion for of. The for of loop will just iterate through each element of an array and give you that element. It won't give you access to the index, which in this case, we didn't need. So we'll say const employee of employees. Here, employees is our array of employees. And then employee, const employee, we're creating a new variable named employee. And inside, we'll have the same logic, which is going to be age sum plus equals employee.age. And when we run this, we should get the exact same output. Let's walk through this code a little bit more to make sure we understand what's going on. The first line of code, we create a variable called employees, and we assign it an array of employee objects. Then we create a variable age sum so that we can add up all their ages into a single variable. Now we enter our for loop, and on the first iteration of our for loop, the employee variable is going to be the first employee. So we take the age sum and we add that employee's age to the result. Then we hit the end of our for loop, and it loops back up and runs this code block again for the next employee. So then it'll run this block again for Bob, age 52, and then it'll run it again for Sally, and then it'll run it again for Mo. Once it's ran this code block for each employee, it will exit the for loop and continue on to the next line of code, which is going to log the sum of all their ages. Afterwards, we'll compute the average age by dividing the sum by the number of employees, and then we'll log their average age. For loops are intended to be used when you know the exact number of iterations necessary. For example, we know the length of our array, therefore we know how many iterations are necessary. If we don't know the number of iterations that we might need, a while loop is what we should use instead. To illustrate this, first we need the ability to roll a random number. So let's first create a function to do that. We'll say function roll, and we'll give it a max value that we want to roll to. That will be of type number, and we want it to return a number, and we want to roll between 0 and that number. To do this, we'll use the math.random function, which will return a value between 0 and 1, not including 1, and then we multiply that by our max plus 1 to get a number between 0 and our max. We'll return this from our function, and then let's try it out before we continue on. We'll try a roll with a max of 500. So when we roll this, we should get some number between 0 and 500. This time we got 41.626, whatever. We don't really want the decimal. We want our rolls to be whole numbers. So what we can do is we can truncate this by using math.floor. Now when we roll this, we should be getting rolls between 0 and 500. The next thing we want to do is we want to create a target value. We'll say 235. And then we want to roll until we reach this target value. So for this, we'll create our while loop. We'll type while. And then once again, we'll use VS Code's IntelliSense to give us a template. And the while loop is a little bit simpler. It's just while condition, run the code block. So our condition is going to be while the current roll does not equal to target. Well, let's create a variable for our current roll. We'll say let current roll, and we'll just default it to -1 so that enters our while loop. So our while loop condition will be while current roll does not equal targets. And inside the while loop, we want to roll until that current value reaches the target. So we'll say current roll equals roll, and we'll actually roll from 0 to 10,000. And out of curiosity, let's go ahead and see how many rolls it actually takes to do this. So we'll say let number of rolls equal 0. And inside the while loop, every time we roll, we'll say number rolls plus plus. After the while loop, we'll go ahead and console log times rolled and the number of rolls. Try to guess how long it'll take to run this application. Remember, we're rolling from 0 to 10,000 until we find the number 235. So we'll run it, and we'll see it found it quite fast actually. It told us it rolled 2,352 rolls in that short period of time. What happens if we change this up to 1,000,000? When we change it to 1,000,000, for me, it still ran extremely fast, and it rolled 1.5 million times in that span of time. So to recap, you'll use a while if you don't know how many times you need to loop. In our scenario, we're rolling until we hit some target number, which could honestly never actually happen. And in the while loop, you start with the while keyword, and then you just give it some condition. And while this condition is not met, it will continue to run this block of code over and over and over. And since we saw just how fast we could roll 1.5 million times, let's talk a little bit about how your computer works. Your computer is going to have a CPU, your central processing unit, and your CPU will have a clock rate. Standard clock rate would be in the range of 2 to 4 gigahertz. What the clock rate means is your CPU can run that many instructions per second. So 1 gigahertz means your CPU can run 1 billion instructions per second. 4 gigahertz would be 4 billion instructions per second. Now we're working with a high-level language in TypeScript. So one line of code could be hundreds or potentially even thousands of instructions. The code we have here is actually probably pretty simple instructions overall. Therefore, we were able to roll 1.5 million times in an extremely short span of time.